start with our section today. We continue with paper 1 SPM 2019, but today we cover the form 5 with the rest of the question. So let's see the question number 27 here. Diagram 21 shows a motion graph of an oscillating spring with a load. So this is wave oscillation system. Okay, so you have spring here. The spring gonna move up and down and up and down. So the repeated motion, we call it oscillation. So this is the graph displacement and time, which A, B, C, or D is an amplitude. So the amplitude is actually from zero, from the equilibrium to the maximum displacement. So in this case, the maximum displacement is A. Okay, so what is B? B is period. Because we have time over here, so the distance between A for B is period. But if this one is distance, meter, then this B is wavelength. So make sure that you check the X and is the unit for that. C, we don't have any significant unit for that, and D also we don't have any significant physical quantity as well. Okay, so let's see question number 28. Which of the following diagrams is correct to show the reflection of water wave? So this is reflection, wave reflection. Okay, so if we make the normal line, if we draw the normal line for each diagram, we can see that any subtle differences that can arise from each diagram. So what are the differences? So the first characteristic is same frequency, same wavelength, and 3, same speed, but different direction of propagation. So this is the characteristic of reflected wave. So first we check if it has the same frequency. So basically we cannot know that because it is hard to identify the frequency based on this diagram because this is just a wavefront. So wavefront is measure wavelength, symbolize wavelength. To visualize the wavelength. So we can not sure about F, but we can assume it must be the same frequency. So let's check for same wavelength by comparing the wavefront. So this is the wavefront. The wavelength is quite small, and then this is the reflected one. It's quite big, so it's not the same. So A is wrong. If we assume it has the same frequency but different wavelength, then that must be different speed as well. So this is wrong. A is wrong. B, again, if we assume same frequency, let's check about wavelength. This is quite big, this is quite small, so this is a different wavelength as well, thus different speed. So B is wrong. C, so if you have a ruler, you can measure both of the wavelength. If you assume the same frequency, these wavelengths are the same. So the speed going to be the same, but the direction is different. So it's perpendicular. So probably C is the correct answer. And D, if you have ruler, you can check the wavelength is the same and the frequency is the same. If you assume that the speed is the same, but the direction of propagation is not perpendicular. What I mean is that the angle is different. The incident angle and the reflected angle is different. So this is okay, 29. Which quantity is changed when sound is refracted? So this is refraction. With refraction. So let's check frequency is the characteristic. Number two, different wavelength. Oh, I'm doing the wrong lambda. Okay, the wrong side of lambda. Sorry, this is the correct symbol. So different wavelength, frequency. Number four, different direction of propagation. But okay, so let's see. Unchanged. Unchanged frequency gonna be changed, gonna be different. Frequency unchanged, velocity will be changed, refracting angle will be. The answer gonna be B. So the rule come here. Every type of wave phenomena, refraction, reflection, diffraction, interference, all the frequency will not be changed. So all the frequency will be the same constant. So remember that. The Ali house is located near to a clock tower. At night, the sound of the clock is louder than during the day. This phenomenon is caused by, so again, this is refraction. Because we have two situations, day and night, basically they have different temperature, thus different density, air density, so it's going to be different angle of reflection. So it's not reflection, it's not reflection, but it is refraction. Interference also wrong. So the answer is going to be C. Number two. So wave interference. Diagram 22 shows a row of students during assembly. Students at row P, R, and T can hear the speech louder. I, students at row Q and S hear the speech softer. So louder and softer, that means they have note and anti-note. Loudspeaker, okay. What should be done so that the speech can be heard louder for all students? So the formula is actually lambda equal to AX over D. A is the aperture, X is the distance between consecutive nodal lines or anti-nodal lines. D is the distance between the source and the screen or the student itself. So we should change them. Should make X as a subject. X is the distance between the two consecutive loudest. So if we make that as a subject, X equal to lambda times D over A. So we should decrease, we should decrease the distance between two consecutive lines, so it becomes narrower. So a lot of students can hear the loud sound. So to do that, we have to decrease the wavelength, we have to decrease the distance between the source and the student, and we have to increase the aperture. So increase distance A, increase distance B, increase wave speed doesn't have any significant effect here. Number 32 wave sound. electromagnetic wave. So diagram 24 shows a spectrum of electromagnetic waves. Gamma is X-ray. So if we price, this should be UV. This should be visible light. This should be R. This should be microwave. This should be radio wave. Okay. So what is A, K, and L? J is UV. K is visible light. And L is microwave. So that is 34. Diagram 25 shows an electric circuit. So Ohm's law, or not Ohm's law, this is charge. When switch S is closed, the reading of ammeter is 50 milliamp. What is the quantity of charge flows through the bulb in 10 seconds? So the quantity of charge, so Q equal to I is 50 milliamp, or 50 times 10 to the negative 3 ampere. Time is 10 seconds. So if you plug in that into calculator, 50 times 10, 0.5 cool. So again, we want to make it into standard. So how much? Only 1. So 5.0 times 1. So B. Number 35. Explain Ohm's law. So basically we have the I here, it must be directly proportional. One and the gradient T R T equal to R. So this is the y-axis, I is the x-axis, so R is the gradient. Number 36, again 26 shows an electric circuit. So this is the ammeter reading when the switch is on. So when the switch is on, closed circuit. So the ammeter reading is the overall current. So we have the overall V here. To find the effective resistance. So for 1 over 4 plus 1 over 2. So this is 2 over 4. 1 over REFF. So REFF is actually 3 ohm. V equal to IR, the Ohm's law, I equal to V over. So it is 12 volt. So 12, 4 over 3. So times 3 over 4. 1, 3 times 3 is 9 ampere. The answer is D. Okay, number 37, EMF. Which circuit is used to determine EMF of a dry cell? So the answer is the correct but It must be parallel to the dry cell. This is correct. But we have use this one correct. Assume that we are connecting parallel like this. It's the same. This is wrong. Emitter should be in series with the dry cells. So the answer is factors of resistance. Diagram 27 shows a light bulb which the filament is made of tungsten wire, very high resistivity, thus it can release a lot of heat. The function of coiled tungsten wire overall in a small space with longer length in small space. So that's why coil wire is very effective here. Increase the electric current is wrong. Increase R resistance. Increase the voltage wrong. Increase the resistance yes. Increase the power wrong. So the answer is C. Okay, 39 EDM electromagnetic on current conductor. Okay, which diagram is correct to show the direction of magnetic fields, positive, negative, so the current flow downwards. So if we use our right hand grid rule, downward, so it should be rotating clockwise. So this compass showing the right direction. This one is wrong. This look like counterclockwise. This one as well is wrong. So A. Diagram 28 shows a current carrying conductor passing a magnetic field because we have a magnetic field, external magnetic field. So this is B. This one, if we use our right hand grid rule, the current into the screen, so it's clockwise. So if we follow from north to south, so you can see that the direction of force downwards because the catapult field pushing the conductor downwards. It has stronger magnetic field at the top, the bottom here. What method is used to determine direction of the force? So we are in motor effect, kiri, so left. Diagram shows a permanent magnet placed on a small trolley. The trolley is pushed into a velocity of 10 meters per second. The reflection of galvanometer increases when the pole reverse doesn't have any significant effect. Decreases wrong because it will decrease the chances for the magnetic field plug to be cut to be changed. Or increases is not it will increase slightly, but it's not much. The velocity of travel increase, yes, this changes here. This basically asks us about Faraday's law. Faraday's law. application of Faraday's law in order to increase the magnitude of induced current. And next, 42, diagram 30 shows an ideal transformer used to charge. What is the current in the primer coil? Primary coil, I think. Primary coil. So we have the power here. So if we assume ideal cases, which is in the questions already given us, so the power of input must be equal to the power of output. So V primary equal to V secondary I secondary. So you want us to find the I primary, so over V. So we I for the secondary, we have V, but we don't have I, but we can find I based on the power. But actually, we don't find I because all of this is actually just with 90 watts. So 90 watts divided by 240 volt for the primary, and then by that we can just plug in that into the calculator. We got 0.7375 D ampere. So as simple as that. But you can as well find I manually, and then if you multiply back with V 19.5, you will get 90. So why waste time? Just plug in 90 directly. Okay, 43 is electric field. I don't know why is this question. It should be earlier, but it doesn't matter. We can still answer it anyway. Diagram 31 shows a candle flame placed between two metal plates that are connected to the extra high tension supply, which diagram shows the correct candle flame when the switch is on. So this is the positive. That the positive ion is weight more than the negative ion, so it will attract it to the negative side. More portion will be attracted to the negative side, so it will look like this, the flame. So the distribution of the flame is not equal, it's more towards the negative side. So this because all the way to the negative side. This is wrong as well. Some of it will go to the positive side, and most of it will go to the negative side. Okay, number 44, electronic CRO. Diagram 32 shows a display on a screen of cathode ray oscilloscope CRO. The time base is set to 15 milliseconds per division. What is the frequency of the wave? So in order to find the frequency of the wave, to find the okay, so what is the period? We can calculate from here to here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 division times 15 milliseconds per division. So how much is it? 120 seconds. Make sure that you convert to millisecond by using the calculator, which is shift 5. 1 divided by 120, shift 5, 8.33. So B. 45. Which statement is correct? Semiconductor. So that means that is the majority charge carrier. Three holes. Okay, majority charge carrier, that means positive. Holes are minority. Wrong. Electrons as minority. Yes. Look with pentavalent. Pentavalent is 5 valence shell. Normal is 4, so we have more electrons. So wrong. We should do if trivalent is 3 electrons. So it's the doped impurities atom acted as doped atom from is acted it's act as so this is answer is B. Diagram 33 shows a fire detector circuit, so this is transistor. Okay, we have relay here. This should be for a fire. We should detect temperature, so this must be thermistor. Okay, what is electronic device P? Thermistor. Okay, LDR for light. LED is for light as well, but it's not detecting light, it's emitting light. Rheostat to adjust it manually, so not suitable for automatic. 47, diagram 54 shows an electronics logic gates. So what is this type of gate? This is OR gate, because if we on this, then the electric can flow through the bulb. If we on this, it can flow to the bulb. But if we close both, then the bulb will not light up. So this must be so the truth table 100 1010. So both has 0. So addition 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. So this must be OR. Okay, so one is the correct add. So this is wrong. Add. This is right. This is right. So B is the correct answer. This add and then we get wrong. So B. 48. Material is more suitable to be used as a container of a radioactive substance. Decay. So if we have memorized the penetrating power tile, paper, aluminum, lead. So lead is the strongest material, the thickest material that can block all of the radiation. 49, radioactive with mass 12 grams has a half-life. Okay. Half-life, which is true about the mass of radioactive substance. So 12 grams, 4 days. Okay, 8 days before. 4, so we should have 24, 48. 8 days before the mass 36. 4 days before 24. Days after, so 4, 6 grams, 4, 3 grams. The mass is 6 grams wrong. 4 days after, 3 grams. So the answer is 50. The equation below represents a nuclear energy. What of reaction fission? Nuclear fission. Because smaller atoms combine, smaller smaller nuclei combine to form heavier nucleus. What is the amount of energy released? Oh no, fission is the heavier nucleus to lighter nuclei. So this is fusion. Fuse together. So what is the amount of energy released through this nucleus? E equal to mc squared. First, we need to find the effect. So initial minus final, because final mass always gonna be less than the initial mass due to the change of the mass into energy. So hydrogen 2.015 AMU atomic mass unit, minus 3 helium 3.017 plus 1 neutron 009 AMU. So what is that? 2 times 2.015 minus 3.009 or 10 to the negative 3 AMU. So what is that? In terms of kilogram, we must multiply with 1.66. So the mass is 66 times negative 27. 30 kilogram, and then we plug in our formula EMC square. C is 3.0 meter per second squared over square. And then we will get 13 joule, which is equivalent to 6.0 negative 30 joule. So that's all for the to complete all the question, and it seems that the question is a little bit easier than the form 4 question because we managed to finish it quite early as compared as yesterday. It took us about 1 hour, but today we just around 30 minutes, something like that. But don't worry, you need to make sure that you're able to answer each question maximum 1.5 minutes in order to fit into the time frame of 1 hour 15 minutes. So we exceed by 15 minutes because we go through a little bit detail last time. So you shouldn't do that. You just need to answer it. So make sure that your calculator is on enough battery. If you need replacement, make sure that you get early. And then you need to know which formula that you have to use for which question. Okay, so that's all for today. And see you soon.